Well, hi, welcome to my shop here. Thanks so much for joining me. It's May 28th. I have a video that I shot yesterday. It's a whole hour of me doing nothing but analyzing the schematic. But today I've come in here anxious to get this radio working properly. And I'm going to admit to something here, which if you've been watching all these videos, you might wonder why I haven't mentioned this. Earlier, I sort of mentioned it, but there's one capacitor in here that I think is in the wrong spot, or could be in the wrong spot. It's a little green guy way in the back here. The way I installed this some number of years ago was I removed the switch. And I removed the switch, I went to put it back in. The way I remember it was a very, very painful experience. Now, part of that back then was I didn't understand the funny way in which these things have been labeled. Well, I got all that straight now. I think the confusion of how it's labeled and things like that led me to put this capacitor in the wrong spot. So I'm going to go after that. Now I've tried in the last few weeks using cameras and everything I can to examine the location of this capacitor. But I have to show you something here. Okay, admission. That's the capacitor there. You see, it's connected on one switch wafer, and the other one is connected there too. Now, let me just check the sizes of these two. 31 and 34. 31.02 and 34.001. They're not the same size. Those are the two. They're not the same size. You know, I may have put the wrong size in here and everything. So I'm going to take the switch. I don't have to actually completely remove it from the radio. What I have to do is disconnect a number of these lead wires, and I can rotate the switch until the back part is at the front. Then I can see clearly what I've done. But I think confusion over the labeling, you know, where these terminals are actually located in terms of the labeling, is what led me to make that mistake. That's my theory today. Every other theory I've had, which always sounds good when it's in the theory stage, falls apart during the work stage. So that's what I'm going to do. So before I do a bunch of unnecessary work here, looks to me like I've got a wire there, a wire here. This blue wire has to be disconnected. There's an orange wire here, but if I'm going to rotate the switch this way, I don't need to disconnect this. Just keep an eye on it. There's this resistor connected here. A little awkward, but I think there's enough looseness down here to rotate again. I have to rotate it about a quarter turn. These, obviously, I can leave the power on there, power cord. And then there's two white wires here. Now these ones I do remember having a hard time figuring out which wire goes where on there. So we can fix that up right now. I just mark the front one here, so I won't make that mistake. Okay. This is that's what I've been trying to avoid all this time. I'm still unsure about this one too, which just doesn't look right. Now, should I try to? So some of these I can certainly unsolder. They'll just pop right off. Now I did make a diagram up of this. Too worried about. And I have how many hours of video? many hours of video. So this is a risk for me as a video maker to start on a project that runs into a snag. And worst case would be a snag that I'm actually responsible for, so it's my own fault. And I end up I put up videos as I do them, so I don't really know how the story's going to go. And I can get into this kind of situation where I'm posting video after video of me running around in circles. That guy can stay there. I don't think that's not even soldered up there. Doesn't matter. Well, if that's the case, I can loosen it if I need to. I don't need to. This green one has to come off here. Let's take it off here. And I use these I'm not tantalum capacitors because I had an excess of them at the time, and I don't know if those are really the best capacitors to use. These kind of hard to see there, that green thing there. I think I'm already in a position. Oh no, I got to do this red one here, which is quite taut. I remember putting it in. Very taut. This is going to pop off. Right, so the risk I take in posting these is that I started looking pretty stupid after a while. Especially if in the end the problem turns out to be, as usual, something relatively simple in itself. And I dragged you as a viewer through all this. It's a problem with how I run my channel because I'm posting every day. I don't really know what's going to happen. So where's my okay, well, we'll use this one. One of my favorite tools appears to be missing. This is what I've been avoiding the whole time. It's jamming up. Let's loosen up. Oops. That's loose enough, eh? Holding it pretty steady here. Let's take it off the wire. Burn your fingers. Click. Not coming off. Doesn't want to come off. Just nip it and be done with it. Put a higher wattage resistor in here anyway. Let's nip it. There's two more wires back here I kind of forgot about on the switch. But, I'm going to prevent the rotation. Something sure is holding it. Maybe just take a little more force on it. Get it around. Something's pulling it. Oh. Okay, so I've got these two wires down here. I've not got much play in them. There. Well, I think that's far enough to do the job. Okay, so very clearly, these two capacitors, one is on this side, one is on that side, and the lead does not come across. was so confused about this switch. I probably thought, well, I'm sure I thought I was doing the right thing, but I don't think that's right. Okay, now how are we going to prove this out? First of all, we got to prove where we are. The red wire, this red wire is coming down and tying to this first capacitor, and it's on the B, A, D, C side according to the way they've labeled things. C. Okay, wait a minute, let's try that again. Their labeling, oh, I didn't read their labeling. Yes, there's their labeling. C. S2C? That's my labeling, the D. S2C, so their labeling method adds up. It's this. What's the capacitor doing on here? So, am I wrong? And it's this one. So this would be, according to their labeling, this is C. D. A. So it's on A, according to their labeling. So you'll go to A and try to spot a capacitor on here. The only one is C28. And C28. And C28. 0.1. Oh! 0.1. So the 0.1, you may not be able to see it, it's here. Now something else someone suggested I do is get this capacitor out of here. You know, I should have. I've just been lazy to take it out. Let's get it out because it's just blocking view. It's not doing anything. A little late in the game to be removing it now, but it's out. There it is. Micro pack. 550 volt surge. Whew. Made in England. August, there's a date on it. August. What do you make that out to be? 55? I think that's probably what that says. Oh, I could say almost anything. Could say 60. Oh, who knows? Oh well, it's old. Okay, you know what? I should have done that way earlier on. Saved myself a lot of neck aches. So that's the 0.1. That's what I wanted to show you. Okay. So looking at the diagram then, their label C, my label D. My label D is this set of terminals is this. And on there, two capacitors. I only got one. Yeah, I think I booped this up. I think this is the problem here. And this is why this thing has been absolutely consistent in its misoperation. No matter what I do, I cannot alter it because it's wired to do what it's doing because I booped up. You know what, I can see that let's look at this with the close-up camera because what I can see is not all that much. Just let me just get control over the focus here before we get going. Okay, focus is set quite close. What I'm looking for on this capacitor, I think I can see a blue covering, yeah. So the capacitor, it looks like it's going back and connecting to an old lead. Oh no, an old lead. So, you know, when I did this, I may have been doing pretty much part for part. Part for part. Look at the state of that switch. It's not in very good condition, is it? Those wafers. Wow. So like this capacitor is hooked up to a wire back there where, can you see it again? Yeah, kind of, a little out of focus, but, and oh, then the wire comes forward. What is going on? I gotta rotate this switch further. We gotta get a really good look at this, or what I'm going to do is I'm just gonna make a new error in it. Why won't you go back further? Who's holding on? Oh, it's these guys again, yeah. Okay, let's come forward. Can't come forward any distance either. This is why I didn't want to do this. I remember it was a horror story. I thought I disconnected this, or did I just look at it and go, look, it's not soldered? Going the wrong way, that's what's happening. It's these. Let me just get a shot of that on camera here. So what I can do here with my software, which I don't normally do, shame on me, is I can take photographs in the middle of me doing this work, which I'm going to do now. I'm going to photograph this image here. Just like this. And save it in the PYE file. Okay. So I have a picture I can come back at. Okay, I got one wire off here. The other one. Like a wire lead sticking way out in there. What is that? That's one of the switch contacts. Is it bent? Oh boy, can I get in there with something? Here's a stick. I think it's fine. I think I'm just... It's that one right there. No, it's not. It's this one right here. Yeah, it's fine. I can see it from a different angle here. Now that I know which one it is, it's no problem. Stop looking for problems. I'm watching this on the TV screen, same as you. How much stuff am I burning here? Not getting there. There we go. They were only tacked on. Okay, can we rotate this guy now? Let's see. Tighten the nut into the wrong spot here. Try anyway. Okay, it's tight there. Now we can see everything for what it is here. That's really weird looking here. I'll show you what I mean. Maybe the problem is something else. So there's a terminal coming, this red wire, and then is that the same terminal? That must be, there can only be one terminal there, so I guess it looks like two shorted terminals, but I think it's just one terminal with two blobs of solder. We have this capacitor. Wow. Which is then connected back here. You can see it's connected to the stub of where the original capacitor was. And is there another piece of wire? What am I seeing there? I'm seeing the lead wire folded back, and I just didn't trim it away. Can we see the size? That says looks like 472. Definitely not the same. 102. 472K and 102K. Okay. I'm gonna take a look at this one up here too. 223K. I'm suspicious that any one of these could be wrong size, wrong place. I was feeling pretty reckless when I was doing this so long ago. So I'm going to verify all that. Just do it off camera, and I'll let you know the painful result. Well, it turns out I got to rotate the switch even farther to get a clearer view of what's going on with it. It's just not. So below me, you can see down here is the page of a diagram I developed showing all the connections here that I'm doing right now. And I use this sheet to compare against the schematic, and you can see all the check marks on here. Okay, so this capacitor with its check mark is this green one right here, and this one, I didn't check it, but I didn't put a check mark, but I did check it, is this one right here. And the only thing I put here was check for jumper, because I couldn't see back here. Well, I'm checking for that jumper now. There's something strange going on back there, for sure, but I can't see. And it's pretty important to see these things in detail. So I'm gonna disconnect this wire here. Loosen this off again. Let's just do it with these. Nope. I don't know if you noticed, but I sense that these are going to slam shut, or these are going to slam shut when I'm doing, trying to use it in certain ways. And boy, do I get my fingers away from all that, because these things bite mercilessly at times. Mercilessly. Okay, go right around. So I've left this orange wire here, and it's starting to interfere. I might as well take it off too. think I could figure out where these wires go just from the schematic. I know enough now to do that. Oh, this one won't come off easy. Sorry about that. It's probably pretty loud. Lots of wire there. I'm just a little bit impatient. I'll leave a little touch of the orange and I'll know exactly where this goes. This switch, I think it's completely free now. What's holding it? These? Coming around. What am I tugging on? Oh, these other wires back here. I forgot about. Okay, I'll get this around as far as we can. That's a pretty clear view. I don't think I can lock it in though. Oh man. There. No, it still wants to turn. Oh man. Just do this. Okay, that's tight. What do we got here? Let's take a look at it with the close-up camera, and we will begin comparing it to the schematic. So there's a red wire that comes here from the center terminal, which I've completely removed. Okay, so that's kind of the entrance in, if you like. A resistor in one way, this is all correct. Going this terminal here is just a terminal for connection purposes. It doesn't go anywhere. You can see the rivet and the stub doesn't go anywhere. So it's just a connection terminal. So going this way, we go through this first capacitor, and it was a 472. So that's a 0.05. I'm not sure. I gotta look to be sure. And that capacitor ties to that terminal. Now you see there's a wire going back. There's a wire going back under it's insulated. It goes under. What does it do? No, there's a so I think there's a wire going from this terminal in the center of the screen. You can see it behind there. It's bare, then there's insulation, and then it goes behind this terminal, comes around underneath that capacitor and ties to the capacitor terminal. And that's the end of it, isn't it? Now there's something else pretty weird in here. Let's see if I can get this on camera. What was it I thought was weird? I thought something was weird. No, I guess not. I'm weird. Oh yeah, so let's look at the diagram here. Let's see if we can relate what we're seeing here to what's on the diagram. So, first of all, so the red wire on my diagram is this blue one. That's the first capacitor. C32. C32, I think, I think I don't know what I was about to say. Because we're supposed to be finding this R20 on, well, why do I have C written there? A, B. Okay, so I you know, on this diagram, these wafers are not in order. Just, you know, another level. You'd think they go like, you know, from front to back, you know, front and back. They're not in order. They got them out of order, which just blows my head off. Let's see if we can see that in their own numbering. Well, it's all mixed up. B, A, C, D. B, A. So if it were in a, it should be B, A, D, C is what it should be. So they flip these two sections around on the diagram just to make my blood come out of my ears on this. I suspect what happened here is, I don't know, in terms of drafting, I won't go into it. So this capacitor, no, you're jumping way ahead. Let's go back up, do this carefully. We have a wire coming from the slider. There is a capacitor shown here up near the slider on the schematic, but there's no capacitor there. The wire comes all the way down and makes its first connection to a point. You know what? This isn't right. This just isn't right at all. Oh, I'm not following the... Yes, I am following the slider. Hold on, your hat's here. So, what's going on here? There's no capacitor in there. Wow, did I you know, quite frankly, I could have gotten so turned around by this numbering inconvenience that they've come up with. I could have done almost anything to this switch. Almost anything's possible. I think we're dealing with these. But, so where's this guy? Well, I'm going to stop the camera. I have no idea what I'm going to post of this. This is a mess. This is terrible. This is just terrible. Maybe I got to start taking senility tests, or is that what this is? This is one big senility test here. I seem to be failing. Okay, my latest assessment of the ABCD thing on this is very simple. There's the two wafers. That's just ABCD. Based on this, A, B, come on. Gotta look carefully. A, B, C, D. So they didn't order these correctly. Or the same. They didn't order these in a real world way. Let's put it that way. So now I think I've convinced myself. Oh my god, this is just like square one here. B has to be there. B is here. B, there's only 2 terminals back here. B only has 2 terminals right on. Before my eye, I'm going to cross out my other notes here because my eye keeps going to them. Oh my god. So now I know A, B, C, D. Hey! Ready to pass grade 1 here. To get to D in grade 1, maybe I have to wait to grade 2 to get to D. So I can continue now. No, just continue. Yeah, just continue. Okay, so I've taken some sober assessment of why I'm going around in circles here. And it's because I don't have a plan of attack. This is a complicated thing. And I don't have a plan of attack. So I'm just stumbling around, being overwhelmed by the enemy all the time. So I gotta go think of a process I can apply to this that will get me through from start to finish. It doesn't have to be anything complicated, it just has to be. Okay, I have a plan. It's not complicated. This is a close-up of those filthy, dirty switches. But I'm going to go through this. I'm going to start over here with this simple one. I'm going to identify every one of these terminals and this sliding contact, or this contact thing here, to make sure I'm looking at the right switch. I'm going to ensure there's no other wires, there's nothing, and it matches this, and I'm going to ensure that these wires go where this schematic shows. I'm going to do it painstakingly, carefully. I've already done this once. In fact, I've done this twice. The first time through yielded this diagram. You know what, right away. I'm not I hadn't even started and I'm already confused about it. Okay, that's what I'm going to work on probably on and off for the rest of the day. That's probably what's going to happen here. Okay, I've actually got that done here. You can see my sheet. I'm making the last reading here on the 15K resistor that's sitting there. Yeah, that's 15K. Would you believe I cannot find a single thing wrong with how this is wired? I have painstakingly traced everything. You see all my red tick marks. Everything works out. This is how I've drawn, you know, this diagram goes with this terminals on this side. You know, this diagram goes with terminals on this side. Turns out it is A, B, C, D in the radio, but this isn't A, B, C, D up here. They B, A, C, D. So, yeah, confusing to me. These aren't in the right order. Okay, but somehow I managed to do it correctly right from the start. So what's wrong with this radio? Oh my god. I'm really getting down now to things like component placement, wire placement, but my experience with it is this oscillation is rock solid in the sense that you can mess around in here all you like moving stuff and nothing will happen to it. But wow, so I got to put this switch back in, see what's happened to the radio. In the meantime, it probably picked up another problem on the way. But judging from my clock here, I think I should go and eat some lunch. Fuel up for more battling. Well, hi, good morning. Thanks so much for joining me here in my shop for another shot at this radio. I'm going to be focused just on reassembling the switch today. I'm going to replace these capacitors here that I used. I never used that type of capacitor. I'm going to put in a more typical tubular capacitor, and just maybe that's the problem. I don't know. And put the switch back in, get the radio operating in whatever state it's going to operate in, and then go outside for a beautiful, beautiful day here. It's just fantastic. What am I doing in my shop? So I'm going to get busy on this, on the switch. Try to get this done as quickly as I can. Okay, so I have replaced the capacitors on here, so these little green guys are gone now. Let me talk a little bit about this just before I go on with stabilizing the switch and putting all the wires back onto it. A number of people have it in their heads that the feedback is turned around in this radio, and it's positive feedback that's coming in and affecting the operation of the radio. So let me talk about that a little bit. I don't think it's possible, because you just couldn't do that. The way the output from the output transformer is right here on this black wire and this orange wire. These two wires are going up to the speaker terminals. This speaker terminal is tied to the chassis directly up in here. So only the orange wire has a voltage on it relative to the chassis. You can see the blue wire connected where the orange wire is. This is the one that's bringing the output as feedback back over here into the switch where it gets manipulated with capacitors and other stuff like that. There's no way positive feedback is being brought over on this wire. But I was thinking about this a little bit. Maybe the positive feedback, well, there has to be positive feedback to get an oscillation. The positive feedback is getting there through some other route which I haven't identified yet. When the volume is turned down on a radio like this, and I hope I'm right about saying this, because there's no output coming out of the speaker, there's no negative feedback heading back to the earlier stage. There's just nothing there. That's when this radio oscillates, when there's no feedback there. You know, the feedback is the signal coming back. It's not something else. Where's all that lead? Well, it means fooling around with the feedback circuit isn't going to help anything, because on that basis there's nothing wrong with the feedback circuit. The problem is some other feedback circuit, some positive feedback circuit that's in here somewhere. That's what I need to track down. So that's just some thinking. Probably completely wrong. Everything's been wrong so far, why wouldn't that be wrong too? But, and there's a long shot here. I'll put the switch back in and everything will work for reasons either unknown, we never know what happened, or these capacitors were the problem, but I don't know how they could be, really. I mean, it's just audio signals in here. There's no RF or anything. Oh well, that's just a little bit of thinking there. I'll get that switch back wired up now. Well, I think I have it back together. Let me just tighten this up a little bit here. Bring my wrenches in here for crying out loud. This ought to do it. Okay, that's not going to rotate. Switch still turns. That's off. Let's start there. Okay, I'm ready to fire it up and see how many mistakes I made, because chances are I made mistakes in this. Tried my very best not to. Yeah, that doesn't work out quite often. So, okay, I just kind of neaten it up here a little bit. I think we'll lay a speaker on here. I took the opportunity to change a couple other parts like the resistor here and a few other things just to get a little more in the zone. I think we're ready. Switch is off. Power on. Nothing happening. Power off. Switch on. Eyes on the dim bulbs. Looking for smoke. Dim bulb's okay. Looking for smoke next. And listening for the crackling sounds. Nope. What is going to happen? Not sure where the volume control is. We're on low voltage. It usually doesn't act up. No acting. Okay. Full voltage. Now, if this thing doesn't oscillate, I'm going to blame it on these little green capacitors. If it doesn't work, I can blame it on me. Apparently it's not working. Well, we got absolutely nothing. Now, what's going on here? Am I not connected? Oh no, it's humming. It's humming along. So, no doubt I've booped something up here. But, interesting enough, oops. Yeah, I booped something up. No surprise to me. Okay, but the main thing is no smoke at this point. Now I have to go and troubleshoot my own work. Oh my god, I was so careful to make sure I didn't make a mistake. Rotated everything back out of view again. That's the whole reason why I did not want to touch this switch, is because it's a bit of a disaster in the making. Okay, time for some coffee, and I'm going to go outside and sit in the sun and ponder, lick my wounds basically. Okay, I didn't even make it to the coffee machine before I realized I'm running this with no antenna, and this is a really quiet radio when there's no antenna. Let's try it again. Let's give it another try. Okay, I hear the hum. Yeah, it's not very good at all. The hum doesn't, yeah. Well, we'll give it a try anyway. Okay, we got volume, we just have no control. We have no feedback. Well, I guess you could call that some kind of progress. Some kind of progress. Somehow I bypassed the volume control. Hey, that's good. Now I'm going to go drink coffee and rejoice in the sun on my deck. Okay, I think I'm ready to go. Just to make the situation extra complicated, I'm going to use this audio signal tracer. I've never actually used it in a real situation. Oh, lots of volume coming out of it. Let's put it down. Okay, I have the signal generator running. It's producing a signal at 455. It's going into the grid of the mixer tube, so it should certainly produce an output from the radio. Doesn't produce an output, I'll go hunting for it with the signal tracer. So let's give it a go. Now I haven't got control over the volume except through controlling the modulation over here. So this might get loud. I don't know. Here we go. There we go. Don't need that. But in fact, I need this hooked up. First time, you know. Boom! Give me a better ground though. Could go right here. Oh my gosh, I hear the tone. Here it comes. Good show to begin with. I'm on restricted voltage. You can see the dim bulbs. You can't, the dim bulbs are on. I'm going to leave it like that for now, I think. For no rational reason. Okay, we hear the tone. The tone for which we have no control over. So, how's it getting to the speaker past the volume control? That's exactly what I'm trying to find out. So let's see what is coming to the volume control. The input to the volume control, the input is wait a minute. Wait a minute here, I got something terribly wrong. I think I wired the volume control wrong. When I put the new volume control in. Okay, let me turn it off just to make sure I don't poke my fingers in there when I'm doing this. I think I made a mistake there on the volume control. Volume control, the slider part. Yeah. What have I done here? Well, that's a good question, so I'm going to stop. What? Well, I think I found the problem. I miswired the volume control. So just have to switch a couple around, and that should be sorted out. Okay, got that sorted out, but actually the situation was even worse. This is the cable that carries the audio to the audio amplifier and out the speaker, and I didn't connect it back under the volume control. So I made a wiring error and then didn't see that there was a wire to be connected. It's kind of hidden from view. Hey, I think, from my experience, this is all par for the course. If you're going to make 5 changes to a radio, let me rephrase that. If I'm going to make 5 changes to a radio, one of them is going to be wrong. Yeah. Let's see, now I'm all excited, but I haven't actually proven I've succeeded here. So, are we safe to go? Still have the signal generator connected. Dim bulbs showing okay. Head, we got there. Now turn the volume. Volume's down. Volume is down. Give it some time. So with the lower voltage, the radio tends to not motorboat. That's where we are right now. Hot diggity dog, eh? Look at that. Now, I'm going to give it full voltage. This is the moment of real truth. Let the truth be known. Oh, crying out loud. Oh, my God. It's better. It's much better, I think. Tone control doing absolutely nothing. Oh no, it's doing stuff. Okay, so I think I can say I got the switch back in. Everything is working incorrectly as it was. And I'm back to what is causing the motorboating. Because it isn't that, and it isn't that, and it isn't anything. It's nothing. Nothing is causing this motorboating when the volume is turned down. So thanks so much for watching this crazy thing. I really am going to have to put this radio aside, but I'm going to give it one more day tomorrow and see if I can't sort this out now. My head is so deep in the game here, I just don't want to put it away. But boy, I have a lot of work to do here on other radios too. So anyway, thanks a lot for watching, and I'm going to head for the sunshine.